What's up, everyone? Welcome back. Patrick here. Moving on to another question dealing with limits in calculus. We got to find the limit as x approaches 3 of this function x squared minus 9 over the absolute value of x minus 3. And then remember, what do you always check with for limits? Can you do a direct substitution? And notice that we can't in this case, because if we plug in 3 for the x values, we would get that indeterminate form of 0 over 0. So we're going to have to figure out a different way to do this. Now, if you've been watching the lecture videos on the site, you've seen other questions where I've dealt with absolute values. And what we want to do is we want to take these absolute values and rewrite them in a way where the absolute value is no longer going to be there, because then we can take this function and graph it, and then graphically we could check what the limit is going to be. So just in general, the absolute value of x minus 3, we can rewrite this as a piecewise function, right? So we know that x minus 3 is going to stay as x minus 3 as long as that x minus 3 expression is going to be positive. And we know that that's going to be positive when x is greater than 3, right? When x is greater than 3, this absolute value, or this expression x minus 3 is going to be positive, which we would just keep positive as x minus 3. Now, if x is going to be less than 3, so let's say, for example, if x is going to be 1 minus 3, that gives us negative 2. And so what do we have to do with the negative 2? Change it to a positive. How do we do that? Well, in general, it's like we're multiplying it by negative 1. So we're going to take whatever that expression is going to be, x minus 3, and multiply it by negative 1 if the x value is going to be less than 3, because that would make that expression negative. And remember, an absolute value always changes a negative to a positive, so we're going to be multiplying it by negative 1. Right? So we took this absolute value of x minus 3 and rewrote it as a piecewise function. Now, technically, I should have put x is greater than or equal to 3 there, or x is less than or equal to 3 here. But because we're going to be incorporating this in this function and at an x value of 3, the function's undefined, we don't really have to worry about that x value of 3, because in this function that we're dealing with, that's not on the domain of it, right? So we're just looking at the intervals when x is greater than 3, when x is less than 3. So now what you want to do is you actually want to incorporate this absolute value into this overall function. So let me think. I'm going to rewrite it over here. So first off, the x squared minus 9, we could factor that into x minus 3, x plus 3. And that's going to be over the absolute value of x minus 3. So now what we're going to do is we're going to take this overall function and also rewrite it as a piecewise function. Okay, so the numerator, that's going to stay the same. So it's going to be x minus 3, x plus 3. And it's going to be over just x minus 3. And that's going to happen when x is greater than 3. Right? So all we're doing is we're rewriting this function. And then for the absolute value, we're incorporating this piecewise function that we made, right, for the denominator. So this would be x minus 3, x plus 3, that numerator staying the same, and that's going to be over negative bracket x minus 3, and that's going to be when x is less than 3, like that, right? So we took our overall our overall original function and rewrote it as a piecewise function. And then notice here, x minus 3's cancel out, these x minus 3's cancel out. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number two, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. So we could rewrite this function here in simplified form as x plus 3. That's going to happen when x is greater than 3. And then there's a -1 here. I'm going to bring it up to the top. And then if you want, actually, you could distribute that negative inside the bracket. So it'd be like -x minus 3. And that's going to be when x is less than 3. Right? I just took this -1, put it in front of the x plus 3 that's remaining, and then I distributed the negative to rewrite it as -x minus 3. And we know that that's happening when x is less than 3. And so from here, notice that we took this function, simplified it to this pretty simple piecewise function, and then this piecewise function is fairly easy to graph at this point, right? So if we take this and graph it, it doesn't have to be, let's just make a quick graph here. It doesn't have to be like totally to scale. You can make a table of values if you want to graph this a little bit more precisely than what I'm going to do. Mostly what we care about is what's happening at that x5, 3. So notice that when x is greater than 3, the function is going to be defined by this line x plus 3. So if we plug in 3 here, we would get a y value of 6. Okay, and that's an upward sloping line because there's like a slope of 1 there. So the line basically looks like that. Again, there's a hole there at that x value 3 because the function's undefined at that x value. Okay, and then this, if we plug in 3 for this second piece, -x minus 3, we would get -6. So that line would be ending right there. It's a negative slope, and so it's looking something like that, let's say. Right, if we took this piecewise function and graphed it, that's how it would look. Or that's how this function looks, right? This function, they're both the exact same thing. If you took this function here, graphed it in Desmos, you would notice that you would get this function right here. And that's how we break it down. We want to change it to a piecewise function. And then from here, we can tell, well, what is the limit going to be as x approaches 3? Well, notice that it's not going to exist, right? Because we are approaching different y values from each side. So the overall limit does not exist. Now, sometimes they'll ask you for like one-sided limits for these kinds of functions. So the limit as x approaches 3 from the negative side, let's call this function f of x. Well, if we approach 3 from the negative side, what y value are we approaching here? Well, we're approaching a y value of -6. So the one-sided limit exists from both sides. Now, if we're approaching it from the positive side, so if we say the limit as x approaches 3 from the positive side or from the right side, well, that's going to be over here, right? So what y value are we approaching as we approach this 3 from the positive side or from the right side? We're approaching that y value of 6. Okay, so the one-sided limits exist, but notice that from each side, they're approaching different y values, -6 and +6. So that means the overall limit does not exist. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.